Yes, good morning, everyone. So yesterday we were discussing about the STP. So in that we have discussed regarding the STP process. So first process in that we have is selection of root bridge, election of root bridge. So what happens that switches exchange the BPDU messages, and the BPDU messages contains what bridge ID, and bridge ID is MAC address and priority number, and default priority number is 32768. So whoever is going to have the least bridge ID, that switches will be called as a root bridge, and the port connected with the root bridge switches will be up, will not be alternate block port. Then it checks for the next step, that is called as the election of root port. So from the non-root bridge, the port that provides the best path to reach the root bridges, that is called as a root port. And even in this case, root port will also not be blocked, right? It is going to be up. Then at last, second last, what it does, election of designated port. So in this case, what it does that it identifies that which particular switch is going to have again the least like whatever is left among them, it will calculate who is going to have the least bridge ID. That particular switch will be having the designated port, and even that port will be up. And at last, it is going to have election of alternate block port, and this particular port will be identified and will be blocked. Right? So in this, we can say that total how many ports we have? One is root port, one is alternate block port, and one is forwarding port. So total ports we have, right? So one is root port. What is root port? Let me write in that one. So what is root port? The port from non-root bridge switch that provides the best path to reach the root bridge. Okay, this is a definition of the root port. We can say that the port from the non-root bridge switches that provides the best path to reach the root bridge is called as a root port. Fine. Then we have is what? Alternate block port. This, the port that remain in blocked state. The port that remain in the blocked state to reduce, or we can say, yeah, to avoid the formation of loop. Okay, this is called as an alternate block port. Which port will be alternate block port? The port that remains in the blocked state to avoid the formation of loop. It can come up automatically if any other port is not working, right? So we can write it can come up if any other port is not working. And why it comes up? To have a reliable communication between the devices. So one is root port and one is called as a alternate block port. And at last, what we have? Designated forwarding port. The port that forwards that traffic and remain in up state. Fine. So one is what? Root port, the port that provides you the best path to reach a root bridge from the non-root bridge switches. Then we have is a alternate block port that is it is going to be in a blocked state to avoid the formation of loop. And one we have is a designated port, or we can call it as a designated forwarding port, the port that forwards the traffic and remains in up state. Correct? Total three types of ports we have. Now we need to discuss about the port states. See, total how many states we have? One is disabled state, one is blocking, listening, then we have as a learning and forwarding state. So what happens now that first the port will be disabled. So we can say if it is disabled, it means it is in the off position. So the port is in administratively off position, that is shut down. So if it is in the shutdown position. So whenever you will be taking the port, first it is going to be in the shutdown position. Next it comes to which state? Blocking state. Now this is like what? Blocking will be like alternate block port. So now whenever your device, any port is in the blocking state, so it takes time to come up. No, yesterday we have seen that. What happens that if any other port was not working, that too also this alternate block port takes a certain time to come up. The reason, because it has to bypass from the blocking to listening, then from listening to learning, and then from learning to it has to come to the forwarding states. So that's why it takes time. So total time that it takes to come from blocking to the forwarding state is 50 seconds. Okay, 50 seconds maximum, 50 seconds it will take. So the switch port is enabled in this case, but the port is not forwarding any traffic to ensure that a loop is not created. In this case, we cannot say that this port is disabled. In the blocking state, the port is not disabled. Port is enabled only, but we can say it is not going to forward any traffic because it will cause a loop. And to avoid that only, it is enabled, but not forwarding any traffic. So the switch does not modify any MAC addresses, any MAC address table, just it can only receive the BPDU messages from other switches. It cannot send that. It can receive the BPDU. And why it is important also to receive? Because if it is receiving, then only it is knowing no, that other ports are working. Correct? And if it is unable to receive any BPDU messages for during time zone, then what happens? It automatically come up. Correct? And to come up only, it bypasses, like it crosses all these states. That's why it takes time. So first it will be in the blocking state, then it will come to listening state, then learning state, then forwarding state. So in the listening state, what happens? The switch port has transitioned from blocking and can now send or receive the BPDU messages. It means in the case of blocking state, it can receive the BPDU messages, right? Whereas in the case of listening state, it can send also, it can receive also. Understand the differences? Fine. But it cannot forward anything. In the listening also, it cannot forward the traffic. Just it can send and receive the BPDU messages. So duration of the state, what we have, it is going to correlate with the STP forwarding time. And the next port state is what? Learning state. So what happened that whenever any changes happens now, so then also the port will be there in the blocking state till 20 seconds. Till 20 seconds, it will be there in the blocking state only. Then it will come to listening state. For how much seconds? 15 seconds. Then it will come to learning state. In learning state, again in 15 seconds. So 15 plus 15, 30 plus 20, 50 seconds. This is total 50 seconds. The range can vary from around 30 to 50. Fine. And in the case of STP, this is one of the demerit where it takes time, 50 seconds. And we do not want to afford this 50 seconds time. That's why we have a concept called as a rapid spanning tree protocol, and that is called as a RSTP. In that case, what will happen? This 50-second time will be avoided. If any other port is not working, like then again this adherent block port will come up automatically without taking 50 seconds time. And that will be the advantage. That is the advantage in the case of RSTP. Then we have is a forwarding state, learning and forwarding. So in learning state, what happens? The switch port can modify the MAC address table. It means still listening, it was not able to modify the MAC address table. It started modifying only when it is in the learning state. So with any network traffic that it receives. So what happens in this? The switch still does not forward any other traffic besides BPDU. In this case also, what it sends and receives? Only BPDU messages. But one difference what we are getting here in learning state, that it can learn the MAC address. It can modify the MAC address table. And if everything is fine, then it will come to the forwarding state. So the switch port can forward all network traffic, can update the MAC address table as expected, and this is the final state for a switch port to forward the network traffic. Right? So one is what? How many states we have? 5. So first we have is a discarding state where the port is disabled. Correct? Or we can say or in off position. Then we have is a blocking state. The port is enabled but cannot forward any traffic. It can't forward any traffic. It receives the BPDU. It only receives the BPDU messages. It does not send. Then we have is a listening state. In this, what happens? The port sends also and the port receives also the BPDU messages. But do not modify the MAC address table. Then we have is a learning state. In this, MAC address can be modified, but traffic will not be forwarded. Only BPDU messages will be exchanged. And at last, it comes to forwarding state. This is the final state where traffic will be forwarded. Clear till here about the port and states. Now what happened that yesterday we have seen also using a command show a spanning tree. So it was showing you the bridge, whether this switch is root bridge or not. And if it is a root bridge, then what is that? How many devices is connected with it, and like what are the port status, right? Now what happens now that if, for example, we have a switch, three switches we have taken, and we have one PC. So by default, what happened now that on a port, the STP will be working here. Then, but in this port, what we have connected? PC. And if this port is like, let's say it is up and suddenly it is not working, then again, what will happen? No, this port will take time to come up. Like how it is happening now, that because of STP states only, whenever you're making the port states changes, it takes time to come, 50-second time, right? Now, okay, that is fine. Then because STP is working, that's why it takes time. So this is, let's say, switch one. Now, why it happens? Because see, in the case of switches, they exchange BPDU messages, and there can be a chance where formation of loop can be there. But this side we don't have the switch now. So why to enable STP on this particular switch? I want that whenever by on any particular switch, if on that particular switch, if n devices are connected, then that particular switch port should come up automatically without having all these times, that is blocking state, listening state, learning state, and forwarding state. The reason, the reason is the PC does not send any BPD messages, right? So for that, we need to enable here port fast. What we have to enable here? Port fast. If you will enable this port fast on the interfaces, so what will happen? It will directly come to the forwarding state instead of coming from the blocking, listening, learning like that. But you cannot, if you will be doing between the switches, let's say between switch 2 and switch 3, you are doing port fast, it will tell you do not enable this port fast between the switches. Why? Otherwise, it will bypass the STP states. And if it is bypassing that, then what will happen? Formation of loop will be there. So where we have to enable the port fast? On the interface, on the port where the end devices are going to be connected. Okay, so see, what it says. That PortFast is a specific configuration feature in Cisco networking switches. It means this is applicable with what? Cisco devices. Designed to minimize the time it takes for a port to transition to the forwarding state. So by default, what happens that a port on a Cisco switches will go through a series of the states like blocking, listening, learning, and then forwarding. When there is any change in the network topology, this can add about 30 to 50 seconds time, which is not ideal for the end devices. So what happens that when you enable the port fast on a switch port, it skips the usual spanning tree states, except what? Forwarding state. Directly it will come to the forwarding state. So allowing the port to immediately enter the forwarding state. This means devices connected to the port fast enabled ports can start communicating over the network without having any delays. Got that point? Why we require this port fast? So let us configure that port fast. Now see what happens. This is interface F0/3. On this switch with interface F0/3, what is connected? One PC is connected. Now we'll forward the timing and see now it is up, right? Now come to this switch, CLI, enable config space T and give a interface F0/3 and make it shut. Give exit. So now it's not working. Now interface F0/3 and make it no shut and give exit. Now see what happens. It will take time. Now it is in adjourned block. Then it will come to listening. Means first it was in discarding, then came to block, then listening, then learning, then forwarding. Still it is not up. It's taking time to come up, right? So if we may forward the timing from here, now it is up. Correct? So it took time. I want that it should not take time because this side my end device is disconnected. Correct? No? There is no any other switch connected that may cause the formation of loop. So I wanted to enable the port fast on this particular interface. How will I enable this? Interface F0/3 spanning tree port fast just spanning tree port fast, that's all, and see what it says here. What is the warning says? There is a warning, no? Port fast should only be enabled on the ports connected to a single host that we are doing now. Now connecting to the hubs, concentrators, switches and bridges, etc. to this interface when port fast is enabled can cause temporary bridging loops. So it means it says here that if you have two different switches and between two different switches you have done this port fast, it will bypass that. And if it is bypassing, what will happen? That port will come up automatically, will cause formation of loops. That's why what is required, where you have to enable this port fast on the port where the end devices are connected. Clear? Now what is the command we have written? Spanning tree, port fast. Give exit. Now you give interface F0/3 and shut. It is down. Now if you will give no shut, it will come up automatically fastly. Interface F0/3 and give here no shut and see. Came up directly without taking time off, listening, learning like that. Correct? This is advantage of the PortFast. PortFast is enabled on the port where the end devices are connected. So it bypasses lesson learning and came to forwarding state. What is the command for this? Spanning tree. PortFast. So it will give you a warning. Okay. If you will do it between the switches, and what will happen? It will bypass this STP states. And if it is bypassing the STP states, then it is going to come up automatically without having all the processes. And in that case, any other devices like it will cause a loop also first thing. Correct? Like if you wanted to do it here, let's say on interface F0 spanning, spanning tree, PortFast. Okay. It's giving you the warning, but it will be enabled there. But may have the effect when the interface is in non-trunking mode. The port first has been configured on the interface. Now, see, as it will be in the trunking mode only, so it is going to have the effect when it is in the non-trunking mode. So now it is a non-trunking mode, right? Give exit, give exit, show spanning tree. So in this case, what happened that this particular F0/1 is what? Forwarding port now. Then next one is what? F0/3 is again forwarding port. And this one F02 is what? Alternate block port. Correct? And this is what? Where is the root bridge now? Root. This is a root bridge. Show spanning tree. And they both are forwarding state. And this is what? This bridge is the root. Okay. So port fast we need to enable only when we have the end devices connected, not between the switches. Otherwise, it will bypass the STP states. Now what happened? Let's consider that you have enabled here port fast. Fine. Then later on, what happened? No, that someone you removed this connectivity and you have taken now a switch. And with that same port only, you are going to connect switch now. Right? What happened? With the same port, on the port where you have enabled the port fast, you remove the connectivity with the PC, and now you have connected a switch. As soon as you get connectivity with the switch, then what will happen? It will be up, bypassing all the states. In that case, it will receive the BPDU. Yes, it will receive the BPDU. Now, don't you think that if anyhow this particular external switch has least bridge ID, then this will become the root bridge? Huh? For example, as of now, my root bridge is a switch, for example. But what will happen that if this particular switch is having a least bridge ID, in that case, what will happen? This particular switch will become the root bridge. But this is not my switch, this is external switch. So in that case, what will happen? All the things will be compromised here, right? So I need to avoid, no, I don't want that any external device should become the root bridge. First thing. Second thing, also it is bypassing. It will cause a formation of loop. Fine. Now what will happen? We need to avoid this. So that's why it is told that whenever you are going to have any port where you have enabled the port fast, then at that time only you have to enable BPDU guard also. What is BPDU guard? BPDU guard is enabled on the port where we have enabled the port fast. And with the help of that, what will happen? If it starts receiving any BPDU messages from any other device, then that particular port will be in the error disabled state automatically. Like you can say, you can consider here that this is on the interface F0/3, you are putting a card who will be checking for the BPDU messages. If it receives any BPDU messages, what it does, it will put the port into the error disabled state. But it does only for only in one direction, receiving the BPDU messages, not in both the directions. So if it receives, it will block. I'm not telling that it will block only when it sends, right? So see, it is written in the PPT. What it does. BPDU guard is designed to protect your network from the potential loop caused by the incorrect switch connections. That is the incorrect switch connection only, particularly on the ports that are enabled with the port fast. So when a BPDU guard is enabled on a switch port, it will monitor for any BPDUs received on that port. It means it is going to check only for what? Receiving BPDUs. So if a BPDU is received or if it is detected, then BPDU guard will immediately disable the port by placing it into the an error disabled state. And this action prevents any possible loops because an end device should never send a BPDUs only who sends switches sends. And now the switches is sending the BPDU messages. So BPDU guard is typically used on a ports where you don't expect to receive the BPDU messages. The port where you don't want to receive any BPDU messages, on that particular port only you will be enabling the BPDU guard, right? So there are different methods of doing this BPDU guard also. It is not that always you will be implementing it on one of the interfaces of the switches. We can have the global command also, where I can enable it on all the interfaces of the switches. Okay. So Cisco Packet Tracer supports interface parameter. So now what will happen? What happened that, okay, this interface F033 will start receiving what? BPDU messages, correct? So if I'm enabling here port fast, so during that time only I will enable BPDU guard as well. Come to interface F0/3. Spanning tree, BPDU guard, enable. This is the command we'll give. Spanning tree, BPDU guard, enable. If we have enabled this, then what will happen? Now see why it is up. The reason because it is connected with the PC, and PC does not send BPDU messages. Who sends switches? So when I will connect back to the switch, what will happen? This port will be in the error disabled state. See now. Changed? In which state it is? Error disabled state. Not working, no, port is down. See? It is in which color? Red color. It means it is down. It is disabled. Why it is disabled? Because it is going to receive the BPDU messages. That's why. What the point? So what does this BPDU guard does? BPDU guard is generally enabled on the port fast when the port receives any BPDU messages, then it put the port into error disabled state. One more statement you can write it here, that it checks only for receiving BPDU. It does not check for the sending BPDUs. Because see, in this case, what happened that, okay, you are telling that it will receive a BPDU from this one. Even this switch can also send the BPDU, no? So it is not worried about that. It is worried about only in one direction, receiving. That's all. Right? That's why have written it checks only for receiving BPDUs. Command to implement is interface number, spanning tree, BPDU guard. Yeah. Clear? Now see, if again I will disconnect this, and if you will again connect to the PC, now even though you have this particular port is not going to receive any BPDU messages because it hasn't connected to the PC, then also this port will not come. This is again one of the demerit. It should come up automatically because we have removed the connectivity and now we have connected to the PC, but they're not coming up. If you want it should come up, then again you have to give manual command. Come to interface F0/3. First you have to give what? Shut. Okay. And then again interface F0/3 and give here no shut. Now it is up. So manually we have to make it up in the BPDU guard. Correct? Spanning tree. Yeah, see, as I told you that always it is not the only interface command we have for the BPDU guard. We have also global command. Means if I will go with the interface number, then it means I am going to implement it on that particular interface of the switches. I want that no, I want to implement it on all the switch interfaces. Let's say the switch has 40 ports. So I wanted to implement it on all the ports. Then I will go with this command. Spanning tree, PortFast, BPDU guard, and at last spanning tree, PortFast, BPDU guard. At last you will write default. Correct, no? Now, in this case, why it happens? Why it is down on this side? Are you getting the point? What happened? Now, if I have enabled between the switches, in this case, this switch was receiving a BPDU. And I have enabled only BPDU guard. It means if it will receive any BPDU, it will block it. Now blocked, this side, what about this side? Why it is coming up? Because here it is alternate block port it was. And alternate block port has to come up automatically. So it came up. Correct now? But this side, what is happening here? It is blocking. So there are two different methods to configure this BPDU card. One is with the help of interface parameter command and one is default. So this is the interface and one more is default command. Default command to enable the BPDU guard on all the interface, on all the port of the switch. What is the command? Spanning tree, PortFast, BPDU guard, default. Clear till here? One more we have that is called as a BPDU filter. So now what is the differences between them, guard and filter? BPDU guard filters the traffic, filters the BPDU or put the port into the error disabled state only when it receives the BPDU messages. But BPDU filter will deny for sending also and for receiving also the BPDU messages. It means it checks for both sending also and sending also, receiving also. But as it checks for both, but it does not put the port into the error disabled state. The port will be in the up state only. Just it will ignore the BPDU messages. Okay. So BPDU filter is enabled on the port fast. It checks for both sending and receiving the BPDU messages. Right? It checks for both. Whereas BPDU checks for what? Receiving. In this, it does not put the port into error disabled state. Port remains up, but ignore BPDU messages. This is the difference between guard and filter. Here also we have two modes, global command and interface parameter. Cisco Packet Tracer does not support BPDU filter command, but I will give you the command. One is spanning tree, port fast, BPDU filter default. So first we'll write interface parameter command. Interface and interface number. What is the command? Spanning tree, BPDU filter enable. Spanning tree, BPDU filter enable. Then we have as a global command that is called as a default command. To enable on the switch only, the command is spanning tree, port fast, BPDU filter default, same thing. Spanning tree, port fast, BPDU filter default. Same. Yes, all the ports can also be converted into the port fast. See, this is the command. One is spanning tree port fast. This is the interface parameter command. And this is a global command, spanning tree port fast default. You can write this one also for the port fast. This is one my interface parameter command. And here we have tried default one. So spanning tree port fast default. Clear? Got the differences between both? What it says that BPDU filter is a spanning tree protocol feature that controls sending and receiving of the bridge protocol data events on a switch. And its primary purpose is to manage and control the BPDU traffic to avoid potential networking uses like loops. And what it does, it controls both sending and receiving of the BPDUs. And here we have discussed one is global configuration and one is interface configurations. Right? Do you know one differences between global and interface in BPDU filter? When you will be implementing the global configuration for the BPDU filter, what it does, it prevents all the ports from sending the BPDUs. It prevents all the ports from sending the BPDUs. It means it will disable what? Sending of the BPDU. Who? Global BPDU filter, right? Whereas interface configuration will filter both, that is sending and receiving. This is the difference. First difference between the BPDU guard and BPDU filter, BPDU guard will disable the port when it receives, then done. BPDU filter, in the BPDU filter, we have two modes. One is global command mode and one is interface command. When I'm implementing using global command mode, in that case, it is going to deny sending of the BPDU messages. It will not allow to send the BPDU messages. Whereas in the case of interface parameter commands of the BPDU filter, it will neither allow nor receive. It means in the first one, it will receive, it will not send. Getting the idea? Whereas in the BPDU card, whether you are implementing it on the per port basis or overall on the switches, in both the cases, what it does, receiving of the BPDUs. That's all. Only in single direction. But filter works in the multiple two directions, depending upon the commands, what command we have given, whether interface command or whether we have given the global command. Clear till here? Which one? Huh? What is the global card? Correct. Yes. So like if I will implementing it on the global, on all the ports of the switches, then it will only prevent what? Sending of the BPDU. Still it will receive that. Okay. Still it will receive. In the switching part, I have to show all these things in the EVNG. So when we used to give the commands, then what will happen? In the global, what will happen? It will keep on sending. You can verify also. It will send. Okay. Every time what will happen? The BPDU messages number will increase. Okay, sorry, sending. So it will receive. When it is receiving, the number will increase, but for sending purpose, it remains constant only. If it has, for the first time, it has sent 11, so it will be there 11 only. It is not going to change that part. Fine. So this is the use case of the BPDU guard and the BPDU filter. And in that, in this also one advantage, your port will not be in the error disabled state. Port will be keep on working. Just it has to ignore what BPDU messages. It means rest other things can work. But in the BPDU guard, everything will be disabled. Correct now? So now, as I told you that in an STP, what happens that it takes time, 50-second times to come up. That's why we have one new concept that is called as like a rapid span tree protocol, RSTP. So STP was defined under IEEE. STP is defined under IEEE 802.1D, whereas RSTP is defined under IEEE 802.1W. This is the standard of the RSTP. So rapid spanning tree protocol is an enhancement of the original STP designed to speed up the convergence of the network. To speed up, we have the concept of the RSTP. Defined in the IEEE 802.1W standard, RSTP provides a faster recovery in Ethernet network by quickly reconfiguring the network topologies in case of changes or in case of any failures. Now, how it provides you faster convergence? See, RSTP can achieve reconfiguration of the network in just few seconds compared to what we have 30 to 50 seconds in the case of STP. So when I talk about few seconds, it means what? Around 3 to 4 or 5 seconds. Right? So here, how many ports we have? See, in this, what happens now? Okay, this is talking about the port. I want to show you about the states. Let me show you. Yeah, these are the states in the RSTP. One is what? Discarding, learning, and forwarding state. What about blocking and listening? Blocking and listening is combined into the discarding state only. See, the switch port is enabled, but the port is not forwarding any traffic. To ensure that loop is not created, this states combines traditional STP states, disabled, blocking, listening. Right? So we can write that in STP, we were having how many states? Disabled state, then blocking state, then listening states, learning, and forwarding state. Whereas in the case of RSTP, we have discarding state.
Vishal, in STP we have disabled.
Hmm?
In STP we had only 4 states, right?
Where?
STP, spanning
State.
tree protocol. We
Like,
had 4,
see,
right?
fine. Okay, we can calculate from the blocking, listening, learning, and forward. That is fine. But when we take or when we connect the devices, like for example, if it is not working, then we can count like as disabled, no? So total we can call it as like a four only, blocking, listening, learning, and forwarding. But actually, when my port is not working, let's say in my scenario, what happened here? I put this port into the error disabled state. Right now it is disabled. So now it is disabled. Now I'm counting from the disabled state. So first disabled, then it will come to blocking, then listening, then learning, then forwarding. right?
Okay. But the time will be not calculated, but the time will be calculated from the blocking state only, right?
Yeah,
Because as a 50 seconds will be from there.
here we will not have that timing.
Okay.
Then it will come to forwarding state. So this three has been combined to form SCADA. Yes. Correct. So RSTP provides what? Faster convergence. RSTP provides faster convergence. Whereas STP takes 30 to 50 seconds time to move port from block state or blocking state to the forwarding state. Now, for this, we need to enable this port fast, right? RSTP, right? Because at present, what happens whenever we are taking the switches, STP is running over there. And because of STP only, it takes time. So how to enable this RSTP? For that, you have to give a command, spanning tree, mode, rapid, PVST. This is the RSTP command in the Cisco devices. RSTP command may vary from different vendors' devices. Why we use here PVST? PVST is like a per VLAN spanning tree. Okay. As of now, what is happening here? Whenever we are running this STP, this STP is for a single VLAN, VLAN number one. Now, I may have multiple spanning tree. Let's say, for example, I may have multiple different VLANs. I have created VLAN number 2, 10, 30, 40, 50, 60, like that. So for each VLAN, I need to have a root bridge. For VLAN number 2, this one is a root bridge. For VLAN number 4, this one is a root bridge, like that. So if you want to have a common STP for multiple VLAN, there we use MST, multiple spanning tree. Okay. As of now, what we are doing here, single single STP, single VLAN. That's why here we have to write the command PVST, that is per VLAN spanning tree. And we need to enable this command on all the switches. Correct? See how? Now, let's take a new topology only because we have configured so many things in this. See, now it is taking time. Even if you forward the timing, now it shows that this is what? My alternate block code. Now come to all the switches. Let me first come to preferences. Yes, now it's visible, right? Ports are visible. Now come to all the switches, CLI, if no enable config space T, host name is S1. What will give? Spanning tree, mode, rapid PVST. This is the command. Spanning tree, mode, rapid PVST. Give exit. Now come to the switch to CLI, S2, spanning tree, mode, rapid PVST. Come to this one. If no, enable config space T and host name is S3. Then give a spanning tree, mode, rapid PVST. Done. Now see what will happen. For the first time, they will take time to do. And once it is done, then it will be decided which one is going to be the block port. Why this port is not working? See, for example, which one is port number will have to. This is which port number? F02, right? So now your F02 is like alternate blocks. Let me do it. Interface F02 or F0. Or this come to the switch only. Here, what will I do? Change this interface number. I'm on switch 2. I'm changing this F0/2 as set. No, give accept. Base F0. Well, do it with the F01, okay? Interface F01 as shut. Yeah, see. So now if it is set, it came up, no? This one is your what? Alternate block port. So when I gave the command, this one for interface F0/1 shut. So as this interface is not working, and then it is going to come up automatically, right? And even if you will give here command as no shut, then it is going to move to the blocking set, right? Without having any time, like 30 to 50 seconds. So now it's faster convergence it is, but we need to implement it on all the switches. Okay. So now the maximum of switches that we were having is having the inbuilt feature of STP. But now the model switch that will come will be having the feature of what? RSTP. And in that, this command is not required. Correct, no? To implement RSTP on all the switches, we need to configure this command. Till here it is clear. So spanning tree. So this first switch is the root bridge, right? Who is the root bridge? First one. Come to second one, CLI, give enable, spanning tree. Face F01. Okay, sorry, come to one face pasty. Spanning tree. See, you will write what? VLAN. What is the default VLAN we are using now? One. Then we will set a priority. Set a priority and give a question mark. This is the range of the priority number. Like what is the priority number? Default 32768. But what is the range? 0 to 61,440. And it says that it should be in the multiple of what? 4096. Your priority number should be in the multiple of what? 4096. So here we are going to change the root bridge. Now you know what is the condition of having root bridge? List bridge ID, no? At present, who is my root bridge? This switch. I want this switch should become the root bridge. For that, what I have to do? I have to make bridge ID less than this one, right? So we'll come to this one. Now, what if I will just change the priority number? See, in that case, it was 32768 on the first switch. I will write here 0. Or I can go with the 4096 also, that is also fine. Because there it is 32768, I have to just lower than that. So I am putting here what? 0. Spanning tree, villain number 1, priority as 0. Then what will happen? This second switch will become the root bridge. You forward the time. And see now, they both are up. And how will you verify? Do show spanning tree. This bridge is the root. Okay. This is how we can change what? Root bridge. So write down the commands to change the root bridge now. This will complete STP. multiple of that, or you can see that you can't give the any other one. You cannot give like 1 or 2, 5, 6 like that. It should be multiple of that. Clear till here? Understood this? Now what happened? You have two switches. This is switch 1. And this is switch 2. This is F01. This side also we have F01. Here we have F02. And this side F02. Now you know here that if I'm having two connectivity between the switch 1 and switch 2, so STP will work, right? I want that STP should not work. I want any other method. So what is the other method? I will bundle these two links to form a single logical link. What we are doing here, that instead of having separate physical links, I wanted to use certain concept where I can bundle these two physical links into a single logical link. When I say logically, it means using certain protocols and steps, I will be doing that. It is not that you will be taking a cables, you will be binding like this. No. It will be physically, it will be different only, but logically, it will be bundled into a single cable. So for that, we use a technology that is called as a ether channel. Okay. Ether channel is what? It is a technology in which multiple physical link multiple physical link will be bundled to form single logical link. It is a technology in which multiple physical link will be bundled to form a single logical link. It is also called as link aggregation or port channel. So in this, we will be having multiple physical interfaces, physical cables, and that we will be bundling into the single logical links. But there is one condition. What is the condition? Whenever you are going to bundle, no, speed should be same. Now what happens? Okay, first we will write the advantage. What are the advantage we have of this ether channel? Advantage number 1. If I am going to, let's say, this particular link is having 100 Mbps speed, and this one is also having 100 Mbps speed, if you will combine them, speed will increase. It will become 200. So speed of the link will increase. Okay. Then it provides redundancy, means it provides you backup. Let's say you have six connectivity, six link. You bundle all the six link. Among these six, one is not working. Then what will happen? Remaining other is working. No, communication will happen. It is not going to affect. That's why it provides you what? Redundancy, backup. It can also provide you generally if it is combining it, so it is like a load balancing, right? So all the packet, all the links will be used for transmitting purposes. See what it says. Ether channel, also known as what? Port channel or linked aggregation, is a technique used to combine multiple physical Ethernet links into a single logical links. It enhances the network performance by combining the bandwidths of the individual links. Okay. Ether channel can combine multiple parallel segments of equal speed. It means speed should same for the connectivity. Now, how many it can bundle maximum? 8. Okay. Now, between the same pairs of the switches, that is going to be bundled into the ether channel. The switches treat the ether channel as a single interface with regard to the STP. As a result, if one of the link fails, but at least one of the link is up, STP convergence does not have to occur. Correct? That's why it provides a what? Backup, tendency, fault tolerance. So we can have what? Uninterrupted connectivity will be there. So we can say, we can write here one more point. STP is avoided in this case. Uninterrupted services will be provided. If one link goes down, then also transmission can take place. It enhances the network performance. But what is the condition it says? It says here that, see, you cannot bundle access port and trunk port. Either you can bundle access and access, or you can bundle trunk and trunk. Same types should be bundled. And like how one more it is telling about you, like link speed should same. So you have to bundle fast internet with what? With the fast internet only. Clear, no? Now, there are different methods of doing this PAG, ether channel. One is PAGP, one is LACP, and one is a static method. So methods to form ether channel. One is static method. In this, we use mode on command to form ether channel. In this, no negotiation will take place. This is the manual method, static method. Then what we have? Dynamic method. In dynamic method, we have protocols. One is PAGP. This is called as port aggregation protocol. Right. It is a Cisco feature. Means this particular protocol will be applicable with the Cisco devices. It has two modes. One is auto mode and second is desirable mode. If you remember, we have discussed DTP, Dynamic Trunking Protocol. There also we were having the same mode, right? So DTP is also a Cisco feature. PHP is also a Cisco feature. That's why mode are same. Auto mode and desirable. In this desirable mode, will negotiate to form ether channel. Whereas auto mode will accept the request to form ether channel. Clear? Next, what we have? LACP. That is link aggregation control protocol. It is of IEEE standard. It means it is applicable with other vendors also, other devices. It has two modes. One is active, and second one is passive. Active mode will negotiate to form ether channel, whereas passive mode will accept the request. To form the channel. Till it is clear? Any doubt?
Vishal,
Mm.
in LSCP, there will be a port of 8 plus 16. So 8 will be the main and 8 will be the backup, right?
Right.
And in PHGP, that will be 8 port, the same like 4 will be backup, 4 will be inactive.
No. Or it will be active.
Oh,
Okay.
okay, then that's what I had to be confused.
So yes, we can write this part as well. Just write forward, write this. That in this maximum
Load balancing also, right? LSCP.
8 links will be bundled. And in this one, maximum 16 links can be bundled. Where eight will be active and rest will be or you can say it will be not like this. It will be bundled in the multiple of 8 links. Okay. Like this we can say. It means total 16 you cannot bundle at one time, 8 and 8 like that. So one, like for the first 8 will be able to communicate, rest it will be for a backup purpose. Okay, so if auto, it will form, huh? No.
No.
Who negotiates? Auto and desirable negotiate. That's why. Auto and desirable, yes, it will form. What about desirable auto? Yes. What about desirable? Yes. This is regarding PAGP. Clear, no? Yeah, you can have all this printout as well. You can make a compiled book for this. But okay, so this is auto desirable and one is like active and passive. Active and passive. Same here also we have active and passive. Yes, now tell me, active.
Yes.
What about active and passive?
Yes.
Passive. Oh, sorry, passive active.
Yes.
And what about passive?
No.
Done. Let me decorate it. Okay. So this is regarding ether channel. So now only the configuration of ether channel is left. So that we'll do tomorrow. We'll do configuration of ether channel, layer 2, layer 3, using starting methods, using PAGP, using LSCP. Then tomorrow we'll start port security. Okay. Stop recording.